Hello everyone, this is Cedric speaking and I want to show you today how to do stacking using JSol'Ex. And I want to do that because I think you would be quite surprised how easy it is to do that and even the quality of the result. So the way I do that, and this is how I publish all my images, is that I do everything within JSol'Ex. And I do that using a script, and for you it's even easier to do that because you can go to the tools menu and you have there script repositories. So if you are familiar with the PixInsight, typically this is the same concept. You have a repositories of scripts and then people publish their scripts, and for JSol'Ex there's actually a SpectroSolHub which has some script repositories and you can publish your own there. So if you click on Browse, then you have the list of all the repositories that are available on SpectroSolHub, and one of them, the first one, is actually mine, so Cedric script. I can click on Add, and when I do that, we see that we have now 3 scripts which are added. 2 of them are about stacking, so there's a calcium stacking and an alpha stacking, and we're going to see that in action. So now how would I do stacking? So what I've done there, you only have to do it once, and once you have the script repositories, you just go into the file menu, you click on batch mode, and you select all your images, like the server files that you want to stack. And now I can go into the image selection. I can select everything I want. I'm going to select the active regions because we're going to have an image that uses that, and then you have this section which is repository scripts, and you see all the scripts which are available, and the ones that we just added are available there. So I'm going to click this line which is H-alpha stacking with unsharp mask, and when I do that it opens script parameters section that we're going to discuss a bit later, so I'm not going to insist on that. I'm just going to click on my selection there and explain what is going on now. So when I do that, JSol'Ex is going to process all my server files. Each of them is about 4 gigabytes. This is because I'm using bin 1. If you were using bin 2, it would be much faster to process because it would be a quarter of the size. So despite that, what the JSol'Ex is doing now is on each file it is actually generating several images, and then once it has processed all the files, it's going to use the output of each file to stack them together. So we see that we're almost done with the files, and when it's done we're going to see what it actually does in terms of stacking. There we go. So now it's running the scripts, and we see this line, consensus reference iteration 1. We're going to discuss what this means later, but this is basically the stacking going on. So now what we see is actually what the script is generating. So these are not the classical images that you see in JSol'Ex. These are really what my script is doing. So it generates an image which is what I call the classic processing. So it's an image which has some enhancement, not too sharp, because we don't do too aggressive processing of this image. And then you have the inverted image, I have the prominence image, colorized version, and I have this improved image which is actually much more aggressive in terms of processing. And this is typically an image that you wouldn't find in JSol'Ex by itself, but the stacking script actually generates this one. So we can move and say that we're looking into this active region there. I can click on this button and then go on the continuum image, and it would show me the corresponding region in the continuum. So something that I have to say about JSol'Ex stacking and the advantages compared to using AutoStacker typically. So if you were to use AutoStacker, it would, well, you would have to select all your individual images, and then you would do that in H-alpha and generate one image that would look basically like that, like it would be the result of the stack in H-alpha. And then say that I want to do the same for the continuum. You would have to select all the images for the continuum and you would do a different stacking. But the stacking for H-alpha would be different from the one in continuum, because the alignment points would be different, the distortions that the software would compute would be different. If you do that with JSol'Ex, it is not the case. Like with this script, we compute all the stacking parameters and the stacking distortion map using this high contrast H-alpha image. So there are lots of places where the algorithm can anchor points where to actually look for details. It computes a distortion map and then it generates that stacked image. But then for continuum, we just reuse exactly the same parameters. So the result of the stacking of this image in particular would be much better than what you would get if you were to use AutoStacker typically. So I kind of disagree with the people who say that JSON stacking is not as good as actually AutoStacker. You have to try it by yourself, and I'm going to show you something else that you can do to give it a try. You go into this ImageMat script, which is my script, and then you just uncomment this line by removing the symbol there, the sharp, and then now I'm going to close all the previous images, and we're going to regenerate this, but we're going to have one debugging animation in addition. So now we have the distortion thing, and what it shows you is the original images on the left, so all the processed images from the stack, and then on the right you have the corrected version by JSol'Ex. So you see something interesting. So there we can see immediately that my images had some clouds, and they actually show up in the stacked image, but yeah, this is some details. But we can also see that the effect of the turbulence is particularly visible. But JSol'Ex does quite a good job at actually correcting that. However, if you're not satisfied, you can decide to spend more time in trying to fix that. So you can go into the details there, into the parameters, and decide to run more the distortion iterations. So in this case I'm going to select 15 and we're going to see what it does. But I'm also going to ask to keep only, say, half of the images in the stack, and I'm going to enable what I call local distortion, which is going to select the best images for the stack, but locally. So it's not going to select the same images depending on where we are on the image. So if I do that, then we run, then in the logs we're going to see that it's computing the distortion on different iterations, and we can see that it computes an improvement of the image after each iteration. So it's interesting to see that in action, because in the end I have selected 15 iterations, but it's going to interrupt before, just because it can figure out that there's actually no improvement. So you can actually select the level of quality that you want just by spending more time in processing. So depending on how many frames you have, you can do that. The second thing I want to mention is this algorithm that I call consensus. So typically stacking software work by selecting one image, which is the reference, and then they align everything onto that image. This is not what my algorithm is doing. It's doing something a bit smarter, in the sense that it will compare all the images pairwise and compare them and compute the distortion map, assuming that the real image is actually something that is the average of all the distortions, and it can generate something which is much better. So you see that he completed after 12 iterations, and we can go into the distortion animation, and then we see that actually the result on the limb is actually much better. There's less wobbling. So that's the corrected image that we can generate, and then the stacking is just about taking all these corrected images and applying a function like a median or a weighted average of all the different frames at 0 points, and then we get this improved image in the end. So this one is actually better than the one we had in the beginning. So you can actually do that with JSol'Ex fairly easily. So I encourage you to play with the parameters that you have into the script. And so typically if you use bin2, you may want to use a different tile size, etc, etc. But yeah, you can try that. Okay, so that's the initial thing that I wanted to show you. But then what I'm doing personally once I have that is that I publish my images, and I publish them using SpectroSolHub. So you can click on this button and click on this share button, and then I can reorder my images. Say I want to have the improved image first, and then usually use the continue and the colorized version, the provenance image. So I can select the images that I want to share. Let's say I want to share Doppler 2. If I want to, well, I never do that, but if you wanted to post-process that outside of JSol'Ex, like say you want to take the images that are generated and process them into Photoshop or GIMP or whatever, you could click that, and then it would let you edit the files. You save the files, same location, and then it would upload that. So I'm not going to do that, I'm just going to publish that. Click on next. It shows me the image that looks the closest to what this reference image is, so we can check the orientation. And now I can say, yeah, this is a live demo of a stack. I'm going to use intentionally a hashtag there. And I could click on this button to publish the session automatically on SpectroSolHub, but that's not what I want to do, because I have this stack is from the past, so it's from May, so I don't want to do that. I just want to show you how to publish. But if you click that, it's going to publish that directly without confirmation on SpectroSolHub. If I don't do that, it's going to go into the staging area into SpectroSolHub. So that's what we're going to see right now. So it's uploading my images, and it's going to open SpectroSolHub, and there we go. So it shows me, yeah, this is on the staging area. If I wanted to publish that to all users, I would just click on this button. If I had, then it would show up here in this index page, and then you can search whatever. But the interest of publishing on SpectroSolHub is that we can do easily this kind of thing. So typically Oscar here has been observing the sun every day for more than 15 days now, 50 days. And we have this beautiful animation, which is the rotation of the sun for 51 days. And if you want to create that for yourself, actually it's fairly easy to do so. I'm going to show you how we can do that. So this is an image from me that I published this morning. So I can click on this observation. You can see that we can compare easily the different images. And then I can click, say, on the continuum image and say that I want to have this rotating disk over days. Well, the only thing I have to do is to click on this time-lapse button, and then it would generate that animation for you. So you can export this as an MP4 or as a GIF. If you look closely, you would see that there are some weird jumps there, and that's because I have missed several days in the observation. So I have 3 days missing there, 1 day missing here, 1 day missing here. So what we can do is that we can complete my sequence with images from other observers. So I could say, hey, why wouldn't I add these images which are from different observers and generate my animation now? And there we see that we have images from me, from Oscar, and there we go. We have this full rotation disk which mixes different images at different resolutions, but at least you can complete the observation. So that's one thing. The other one that we can do is that we can generate a synoptic map. So we can select all these images. So I'm going to uncheck all these and just select my images there. Remove this one from Oscar. And I can click on this button, generate a synoptic map. And what we're going to see is a planisphere of the observations that I've made. in these days, and you see the location of the active regions. We can see that as a globe and rotate if we want to. We can enable or disable the labels for the active regions. So that's one option. The other one that you have is that you can generate sunspot trails, and that would generate this image where you see all the positions of the sunspots around days. So before, I don't know how much time it took you to do that, but yeah, it's fairly straightforward to do with SpectroSolHub. And last but not least, what I want to show you is that typically if I go on this image and we have this beautiful active region there, so we can annotate, so it's 4478, and say I want to see how it looked over the days. I can select the active region, select the frames. Actually he only observed for a couple of days, so let's go and, well, actually I can do that. I can select this guy and include other compatible images, and then we have 4, and I can click preview and we see the images of the active region progressing as we have observations in time, and I can generate instead either a GIF or an MP4 or this collage image that you have here, where we have the dates and then the shape of this active region. So it's super easy to do. So this is all I wanted to show you today. So as a summary, I don't use any external software for stacking. I just have this script which works beautifully for me. I'm not going to say that it is perfect, it is not. Maybe you will get better results with AutoStackit, but for me, like, it took 1 minute just to do all the stacking on my machine, like of 6 images. So, and yeah, 4 gigabytes each. So it's fairly amazing for me to do that in such a short amount of time. So I hope you enjoyed the video, and talk to you later. Bye bye.